Okay, here are the polynomial inequality notes. Again, fairly short because we are going to draw on what we did with rational inequalities. Okay. So a polynomial inequality, suppose we have some polynomial function, we're going to call it p of x, and it's going to look like, a number times a variable raised to a power, and hopefully in descending order, just because that's how we're kind of used to seeing it. Okay. If we are looking for where the polynomial is greater than 0, that means we want the y values. We want to know what x gives us the y values that are positive, greater than 0. We can have equals involved as well. That just means we also want the 0 included. P of x less than 0. So I'm going to clean this up a little. We want the x values that give us negative y values. So let's refix this. Want the x values up here that gives y that are positive. Sometimes you got to say it out loud to realize that you want to do it differently. So we're going to start with this quadratic, example 1. And I'm going to go ahead and start by factoring. Only way I can get x is x and x. 4 and 1 is going to be the only way I can get a 3. That's x minus 4 and x plus 1. So x equals positive 4 and x equals negative 1. Okay, I'm going to plot those on here. Now, I'm not worried about the vertex. I want to know where this is positive. So I am going to go ahead and divide up my interval the way we did before. I know I cannot use negative 1 or 4. This is strictly greater than, not greater than or equal to. Now what I'm going to do is pick values of x and see if I get a positive or negative y. I'm going to start with this chunk in the middle, just because it's easy to plug in 0. And I'm going to plug it into factored form. X equals 0. I got 0 minus 4 times 0 plus 1. Negative 4 times positive 1 is negative 4. That gives me a negative value between negative 1 and 4. Okay, that's not what we're looking for. We're looking for positives. So let me pick something over here. Let's try negative 2. And whatever value negative 2 has, it's going to be everything to the left of negative 1. So my x is negative 2. I get negative 2 minus 4 times negative 2 plus 1. Negative 6 times negative 1. That gives me a positive 6. That's actually part of the interval that I want. Okay. So I know my solution is going to contain this interval, negative infinity to negative 2, parentheses, because we cannot use negative 2. Or sorry, negative infinity to negative 1. That's my cutoff right here, which is when you look at one thing and say something else. And I know I cannot use negative 1 because we are looking for this to be strictly greater than 0. At negative 1, it equals 0. So we're not going to use that. So let's pick another number over here, 5. We have 5 minus 4 times 5 plus 1, I get 1 times 6, which is positive 6. So everything over here is also going to be positive. And that goes from 4 to infinity. Now, if I were going to graph this, I know my low point would be halfway between. My leading coefficient is positive 1, so if I'm super comfortable with how I graph these, I could have figured this out just by sketching the graph, or knowing that this is going to open up. And so outside of my 2 zeros is where I'm going to have positive values. Okay. So let's start with example 2 here. Let's get out of the hot pink. First thing we've got to do, and I'm going to slide this over here. I'll go down below. Is we got to move everything to the same side. This has got to be set equal to 0. Because that 0 is where we change from positive to negative or negative to positive. And we definitely want to make sure we've got that cut off to help us out. I'm going to factor out the x, and I'm left with 4x squared minus 7x minus 15. I'm going to go 4x and 3. Which will give me a 12, and then 5x, 12 minus 5 is 7. So I need this to be negative, this to be positive. So a review, my linear factors are x, 4x plus 5, and x minus 3, which means my zeros are at x equals 0, x equal negative 5 over 4, and x equals 3, which means my intercepts are at 0, 0, negative 5 fourths 0, and 3, 0. This one we're going to go strictly by graphing, okay? This is a cubic. My leading coefficient is positive, right? The number attached to that variable with the highest power, which means that I know that this gets treated like a positive. It goes up to the right, okay? Again, I don't care how precise my graph is. I just want to see where this is above and below the axis. So we're going to go with that. I want the y values right here that are less than or equal to 0. That happens over here, and the equal 0 part, and that happens right here. So my solution set, we're going from negative infinity. Remember, we cut this off with the x's, negative 5 fourths. Square bracket, because we can include the negative 5 fourths. That gives us our 0. And then 0 to 3, again, square brackets on both of those, because we want the 0 included.